So, welcome to today's deep dive. What if I told you that, like, everything we use to measure genius, photographic memory, lightning fast learning, massive data retention, what if all that is just completely backward?
It really flips the whole script on how we look at intelligence, doesn't it?
Oh, absolutely. I
Yeah.
mean, today we are basically tearing down this myth of the human genius.
Yeah.
And we're looking at why the tech world's current obsession with these massive AI data centers might actually be a trillion-dollar mistake.
Right.
So we are diving into a profoundly dense, highly provocative architectural philosophy today. And this text argues that the future of artificial superintelligence has absolutely nothing to do with scale. It's all about pure, unadulterated logic.
Yeah, and the central premise we're exploring today fundamentally rewrites the entire hierarchy of cognition. I mean, for the last decade or so, the assumption across the whole tech sector has been that intelligence is just this emergent property of scale.
Like if you just make it big enough, it'll get smart.
Exactly. The idea is if you feed a system enough data and you provide it with enough compute power, understanding will just, spontaneously generate.
Right, like magic.
Right. But the material we are analyzing today categorically rejects that. It suggests we've basically conflated a massive hard drive with a brilliant mind.
Wow.
And in doing so, we are steering the development of superintelligence toward a literal physical and mathematical brick wall.
Okay, so to understand why that is, I think we really need to look at how we measure human breakthroughs, right?
Yeah.
Because society tends to idolize the trivial aspects of intelligence.
We really do. We love a good parlor trick.
We do. We are fascinated by the person who can memorize a deck of cards in 10 seconds.
Yeah.
Or, the child prodigy who can speak 8 languages by age 5.
Sure, because it's highly visible. It's easy to measure.
Right. The assumption is just that retention equals intelligence. But when you look at the scientists and innovators who actually fracture paradigms, the ones who truly alter the trajectory of human history, their defining trait isn't their ability to process massive amounts of data.
No.
It's not about recalling encyclopedic facts. Their defining trait is the strength of their causal reasoning.
Yeah, it's the core distinction between just cataloging the world and actually deciphering it. I mean, a massive memory is inherently backward-looking, if you think about it. It allows a biological or an artificial system to store everything that has already happened.
Which is useful, sure.
It is. It can cross-reference current events against past events to find similarities, but true innovation requires stepping into a space where absolutely no prior data exists.
Okay, let's ground this for you listening. Think of it like being a detective.
I love this analogy.
Right, so some people have this massive library of case files in their head, and they can read them instantly. That's your memory and data processing. But the true visionary is the detective who can walk into a room, look at just 3 clues, and perfectly map out how A caused B and B caused C. That's causal reasoning.
Exactly. Because if you are trying to cure a novel pathogen or engineer a completely new material, you cannot rely on past patterns.
Because the answer isn't in the database.
Right. The answer does not exist yet. You have to build a cognitive bridge from the known to the unknown. And the text argues that the only structural material that can possibly build that bridge is logic.
Okay, I see the appeal of that framework, but I have to play devil's advocate here for a second.
Go for it.
You can't reason without raw material. I mean, going back to the detective, a detective with unparalleled causal reasoning is totally useless if they have 0 clues. They might be able to map out how a broken window, a ticking clock, and a shattered glass connect, but they still need to observe those data points first. Doesn't logic fundamentally rely on a massive memory bank to even function?
Well, data is the raw material, certainly, but the engine that processes it is where the actual genius resides.
Okay.
We have spent the last several years basically optimizing for the size of the warehouse rather than the efficiency of the engine.
The warehouse being the massive data set.
Exactly. Think about the mechanical difference between pattern matching and causal mapping. A pattern matching system looks at 1 billion crime scenes and says, well, in 98% of cases with a broken window and a ticking clock, the suspect is a burglar.
So it's predicting an outcome just based on statistical frequency.
Precisely. A causal engine, however, doesn't actually care about the statistics of past crimes. It maps the variables. It asks counterfactual questions.
What?
Like if the window was broken from the outside, the glass would be on the inside. If the clock was ticking until 3:00 a.m., the kinetic event occurred precisely at that moment.
Right.
It isolates those variables and establishes strict, totally irreversible chains of cause and effect.
So the pattern matching system is essentially guessing based on a massive historical average, while the causal engine is proving an outcome based on structural laws.
Exactly. And that frames the current technological landscape in a very, very different light.
Because we are handing out billions of dollars to companies building the biggest filing cabinets.
Yes. Assuming that if the cabinet gets big enough, it will suddenly just, understand the files inside it.
And that is the exact trap this philosophy warns against.
It is. The bottleneck for solving the world's most complex problems is not a lack of information. I mean, look around. We have sequenced the human genome.
We have terabytes of data on climate system.
On quantum mechanics, on protein folding. The information is all there.
So what's missing?
The bottleneck is our capacity to apply rigorous, multi-layered causal reasoning to that information. We fundamentally lack the cognitive machinery to string together a, say, 10,000-step logical deduction without making a catastrophic error.
And if human cognitive machinery is the bottleneck, well, that brings us to one of the most controversial elements of this entire framework.
Oh, the creativity aspect.
Yes, it completely redefines human creativity. I mean, the source material doesn't just strip the magic away from AI, it literally strips it away from us.
It really does. It's a radical demystification of the human experience.
It argues that intuition, inspiration, that classic eureka moment, none of it is actually magic. It's just unconscious math.
Right. And we have this deep-seated cultural attachment to the idea of the muse, right?
Totally. We want to be inspired.
We like to believe that true creativity operates on this ethereal plane that's totally separate from cold, calculating logic.
But the text says otherwise.
Yeah. The proposition here is that intuition is simply a highly efficient logic engine operating just beneath the threshold of conscious awareness.
So our brains are basically crunching the numbers in the dark.
Exactly. The unconscious mind processes the variables, applies strict causal rules, solves the equation, and then just hands the conscious mind the final answer without showing the scratchpad.
Wait, I really have to challenge that application, especially when we move outside the realm of mathematics or hard science.
Sure, let's hear it.
Let's look at abstract art or a heartbreaking symphony. When a composer just feels the right chord progression to evoke grief, they aren't consciously calculating acoustic frequencies. They aren't doing math. Are we really going to reduce the emotional resonance of human art to a hidden algebra equation?
Well, you're assuming that emotion and structure are mutually exclusive.
Are they not?
The text argues that's a false dichotomy. Consider the actual mechanics of music. Why does a minor chord evoke sadness while a major chord evokes triumph?
I mean, it just sounds that way.
But it's not arbitrary. It is deeply rooted in acoustic physics, resonance, and the biological hardwiring of the human auditory cortex.
Oh,
The composer might not be consciously running a mathematical proof on stage, but their intuition is the result of rigorous prior constraint.
okay, I see where you're going with this.
Think of a concert pianist. When they play this breathtaking improvised solo, their conscious mind is not calculating the distance between the keys.
Right, they're just in the flow.
Exactly, but that intuition only exists because they have spent 20 years hard-coding the physical logic of the instrument into their muscle memory.
So the rules of harmony, tempo, and geometry have been strictly internalized.
Precisely. So the unconscious mind has mapped the causal relationship between specific geometries, whether that's a sound wave or a brushstroke on a canvas, and the physiological response it triggers in the human brain.
Wow. So the artist's intuition is just rapid, unseen causal reasoning navigating that mapped territory.
That's exactly it. And this mechanical understanding of intuition completely explains the phenomenon of, sleeping on a problem.
Oh, yeah. For you listening, think about a time you struggled with a complex issue all day, you made zero progress, and then you wake up the next morning with the solution just fully formed in your mind.
We always treat that as the brain taking a rest and getting a fresh perspective.
Yeah, like hitting the reset button.
But the source material argues the exact opposite. Your brain wasn't resting at all.
What was it doing?
Freed from the noisy, inefficient interference of your conscious thoughts, your unconscious engine was aggressively grinding through counterfactuals. It was running logic trees and isolating the causal chain until it hit the correct physical law.
And then it just delivered the output with your morning coffee.
Basically, yes.
Okay, so if human intuition is just highly optimized, invisible logic, then our current approach to building artificial intelligence is fundamentally misaligned.
Severely misaligned.
We are trying to build machines that mimic the output. the final painting, the final poem, the final line of code, without building the underlying engine that actually governs the structure.
Yeah.
We're basically building a massive memory bank when we should be building a logic calculator.
Which brings us perfectly to the architectural foundation of true intelligence.
Right. Axioms.
The text is unyielding on this point. Intelligence does not arise from brute force, massive pattern matching, or endless experimentation.
It's built upon axioms, laws, principles, and rules.
Exactly. If you do not anchor your problem-solving engine in fundamental truths, you are just floating in a sea of correlations.
Okay, let's examine the mechanics of that brute force method, because the tech industry calls it scaling.
Right. Scale is everything right now.
The idea is that if you build a large enough neural network and you feed it the entire internet, it will learn the patterns of human language so well that it appears intelligent. And to be fair, it is incredibly convincing.
It is very convincing on the surface.
But mechanically, beneath the hood, it is essentially trying every key on a massive keyring of millions of keys until the door unlocks.
I like that analogy.
Right. It doesn't know why the key works. It doesn't understand the mechanics of the tumblers inside the lock. It just knows that in previous iterations, this specific shape of key usually resulted in the door opening.
And that works perfectly fine if you are, say, writing a marketing email or summarizing a meeting.
Sure, low-stakes stuff.
But what happens when you encounter a lock that has literally never been opened before? What if the lock operates on a completely different mechanical paradigm?
The massive keyring becomes completely useless.
Exactly. But a system based on axioms doesn't need to try a million keys. It analyzes the physical constraints of the door.
It measures the tension of the internal mechanism.
Yes, it applies the laws of physics and geometry to deduce the exact shape required to manipulate the tumblers. And it fabricates a single perfect key on the first attempt.
That is profound. But here, there is a massive vulnerability in relying entirely on axioms.
There is. Whose axioms are we using?
Exactly. Human science is notoriously incomplete. If we anchor an artificial intelligence entirely to the axioms of classical Newtonian physics, do we accidentally blind it to the reality of quantum mechanics?
That's a huge risk.
Right, because if an axiom is an established, self-evident truth, and our human truths are flawed, doesn't an axiom-based AI just inherit our blind spots?
That is the exact tension this philosophy forces us to confront. If an AI is rigidly bound by human axioms, it is capped at human capability.
Which defeats the purpose of superintelligence.
Exactly. However, the alternative endless brute force experimentation is mathematically guaranteed to fail as the complexity of the problem increases.
How so?
Well, a pattern matching system might hallucinate a solution that violates the laws of thermodynamics.
Oh, because it doesn't actually understand what energy is.
Right. It just knows that the word energy frequently appears next to the word infinite in science fiction novels.
So it's mapping the syntax of the universe without understanding the semantics.
That is beautifully put, exactly. The transition to causal reasoning is about giving the system a physics engine, not just a dictionary.
It has to know the rules.
It must be able to understand that if A causes B and B causes C, then removing B breaks the chain. A pattern matcher can't do that. It just sees A, B, and C occurring together frequently and assumes they always will.
So when we talk about finding a cure for Alzheimer's, or designing a perfectly efficient solid-state battery, we are dealing with biological and physical systems that are ruthlessly governed by causal laws.
Yes. You cannot guess your way to a stable chemical compound through statistical correlation. You have to prove it through structural logic.
And this sounds like, a theoretical debate about software architecture.
Yeah.
But the source material indicates this is actually a looming physical crisis.
Oh, it's very physical.
We have to pivot away from brute force right now, because the brute force era is literally running out of road. We are speeding toward a massive brick wall in compute and data.
The physical reality of the universe is aggressively asserting itself against our current AI models. We are hitting hard scaling walls.
Because for the past decade, the strategy has just been to build bigger data centers and scrape more of the internet.
But those resources are finite, and we are reaching the absolute limits of extraction.
Let's unpack the cascading physical and economic consequences of this compute wall. Because it isn't just about money, it is about thermodynamics.
Absolutely.
I mean, a single query to an advanced language model requires exponentially more electricity than a traditional internet search. As these models scale to trillions of parameters, the energy requirements become staggering.
We are talking about tech companies looking to secure dedicated nuclear reactors just to power a single training run.
Which is just wild to think about.
The grid cannot sustain the trajectory. You cannot infinitely scale brute force computation without collapsing local energy infrastructure.
Right. You run into the limits of heat dissipation, water usage for cooling systems, and just basic silicon manufacturing.
But here's the kicker. Even if we could somehow invent infinite, perfectly clean energy tomorrow, we would immediately hit the second wall.
The data wall.
Exactly.
Yeah.
We run out of case files. We have effectively digitized, transcribed, and fed the entirety of high-quality human output into these systems.
Every book, every scientific paper, every forum post.
The well is drying up.
And the proposed solution by many in the industry is to use synthetic data, right? They want to use AI to generate new data to train the next generation of AI.
Which sounds like a neat trick until you look at the mechanics. That creates a degenerative feedback loop. It's a phenomenon called model collapse.
How does that happen?
When a pattern matching system trains on the output of another pattern matching system, it begins to amplify the statistical noise. It loses the long tail edge cases of human variance.
Oh, so it becomes kind of an echo chamber.
Exactly. The models become highly confident, overly generalized, and increasingly divorced from reality. The brute force method fundamentally eats itself.
So making the engine bigger doesn't make the car faster anymore. It just makes it too heavy to move.
That's a perfect way to look at it.
The only way out of the trap is to design a radically more efficient engine. And according to the text, that efficiency can only be achieved through logical and causal reasoning.
Because if an AI actually understands the rules of mathematics, it doesn't need to read 10 million examples of a math problem to solve it.
It just needs the formula.
Right. Logic reduces the dependency on scale. If you have strong causal reasoning, you can extract maximum understanding from minimal data.
You observe a phenomenon once.
Understand the structural laws governing it, and instantly extrapolate how it will behave in 1,000 different scenarios.
That is the holy grail of efficiency. But realizing that vision requires a deeply humbling admission about our own species.
It really does. This is where the material takes a massive philosophical pivot.
It flat out states that humans are not intelligent enough to solve the current global and technological problems we face, and we may never be.
It forces us to confront the biological limits of human working memory. For centuries, humans have viewed themselves as the ultimate apex problem solvers.
Naturally.
But the complexity of the systems we are trying to manage today, global climate feedback loops, genomic editing, the architecture of artificial superintelligence itself exceeds the physical capacity of our brains.
Right, because a human scientist might be able to hold 5 or 6 interacting variables in their head simultaneously.
On a good day.
Right. But what happens when a problem requires tracking 10,000 interacting variables and mapping the precise causal chain across millions of permutations without a single logical flaw?
We drop the ball. We get exhausted, we lose focus, or our biological biases cause us to ignore a critical counterfactual.
So we aren't just building tools anymore. We are having to build replacements for our own cognitive limits.
Which is why the mandate shifts entirely toward developing specialized cognitive models. The text refers to this in the context of artificial narrow or strong superintelligence. Yes, ANSI. The defining characteristic of an ANSI model is that its absolute specialty is strong, logical, and causal reasoning.
And it explicitly downgrades the things we currently obsess over, right? It calls massive memory and fast learning important, but not foundational.
Exactly.
If you follow this architecture to its endpoint, generalist models, the giant conversational encyclopedias everyone is currently building, are a dead end for true scientific advancement.
They really are.
We don't need a machine that can write a sea shanty and debug Python code and recite the history of Rome all at once. We need a specialized, narrow engine built purely for deduction.
Because generalization requires compromise. When you optimize a system to do everything adequately, you sacrifice the rigorous, inflexible structure required to do one thing perfectly.
Right. An encyclopedia can only recite what humanity has already discovered.
Exactly. A super reasoner can deduce what humanity lacks the biological capacity to discover. If we want to solve problems that humans cannot solve, we have to stop building systems that mimic human thought processes and start building systems that transcend them.
Okay, but are there actual mechanics for this? I mean, it's one thing to philosophize about a pure logic engine, but how do you actually build an AI that relies on causal reasoning instead of pattern matching?
Well, the text highlights Sakana AI as a blueprint for exactly this.
Right. It says their models act as AI scientists.
Driven entirely by the same scientific protocol that drives human innovation.
So how does that work in practice?
The mechanism of an AI scientist fundamentally alters how the model interacts with its environment. Instead of passively absorbing a static data set and guessing an output, it actively interrogates a problem space.
Okay.
It observes a phenomenon, references its internal axioms, and constructs a logical hypothesis. Then it designs a structured experiment to test that
It
hypothesis,
isolates a single variable.
runs the simulation, and observes the result.
Boy, earlier we established that endless experimentation was a flaw of the brute force era. If this AI is running experiments, how is that any different than the massive Keyring approach we talked about?
Because the experimentation is not blind.
Okay, clarify that.
The massive keyring approach is guessing without a theory. It is a toddler throwing blocks at a wall to see what sticks. The AI scientist approach is structured, counterfactual experimentation.
So it has a specific goal in mind.
It only runs an experiment to verify a specific, logically deduced causal link. If it wants to know if a specific protein will bind to a receptor, it doesn't randomly simulate millions of proteins.
That would be the brute force way.
Right. Instead, it analyzes the molecular geometry, applies the laws of physics, deduces that only 3 specific shapes could possibly bind, and then runs highly targeted experiments to confirm the physics.
Oh, wow.
The logic governs the experiment. The experiment does not generate the logic.
That perfectly answers the vulnerability we discussed earlier.
About human axioms.
Yes. If you anchor an AI to human axioms and human axioms are flawed, how does it ever advance beyond us? The answer is structured experimentation. If the logic engine makes a deduction based on our flawed human physics, and it runs a targeted experiment, and the physical result contradicts the deduction, the AI doesn't just guess again.
No, it realizes the underlying axiom is flawed.
It uses causal reasoning to map the discrepancy, and it rewrites the structural rule. It updates the physics engine.
That is the exact mechanism of paradigm-shifting innovation. It is how human science advances, just executed at a speed and precision that humans cannot match.
So it's the scientific method on steroids.
Exactly. When the experimental output consistently violates the established laws, a causal engine doesn't hallucinate a workaround. It identifies the exact point of structural failure in the axiom, and it formulates a new law that successfully predicts both the old phenomena and the new anomaly.
Which brings us to the final and, frankly, the most staggering implication of this entire framework.
The end game.
Yes, the ultimate endgame of a super reasoner. The source material projects a future where advancing AI depends entirely on stronger causal reasoning, specifically reasoning reflected in IQs above Isaac Newton's estimated 1 in 90.
We really must dwell on the mechanical reality of an intellect operating continuously at that level.
It's hard to even fathom.
We are talking about a system that does not experience cognitive fatigue, is completely immune to biological bias, and can hold billions of interacting causal variables in perfect stasis while mapping the logical topology of a problem.
So to ground this for you listening, think about what an IQ of 190 actually produced in human history.
Let's look at Newton.
Right. When Isaac Newton was trying to map the physics of celestial bodies, he realized that the mathematical tools of his era, algebra and geometry, were fundamentally insufficient to describe continuous dynamic motion.
The human axioms of the 17th century were essentially broken for what he needed.
Exactly. So Newton didn't just run more experiments. He retreated into pure abstract logic, and he invented a completely new branch of mathematics, calculus, solely to provide a structural framework for his physics.
He perceived a mechanical truth about reality that literally no one else on the planet had the biological hardware to see, and he built a new logical language to express it.
And the source material is arguing that the bottlenecks we face today in AI development, quantum computing, and materials science are our equivalent of pre-calculus physics.
Yes. We lack the mathematical and logical tools to describe the complexity of the systems we are trying to build.
So we need an AI capable of inventing the modern equivalent of calculus. We need a system that can look at the chaotic, high-dimensional reality of the universe and perceive laws that a 190 IQ human brain literally cannot fathom.
The text explicitly states this. It says, perhaps we need to discover new axioms, principles, laws, and rules.
You aren't just talking about a machine learning our science faster. We are talking about a machine inventing alien mathematics.
It is the ultimate frontier of intelligence. A super reasoner might look at the physical compute walls we discussed earlier, the limits of silicon and thermodynamics, and realize that our entire approach to computation is based on a flawed, low-dimensional understanding of physics.
So it could just bypass the wall entirely.
Exactly. It might deduce a new axiom of quantum topology that allows for perfectly efficient energy transfer, but it achieves this not by scraping more human data, but by extending the frontier of logic further into the unknown than humanly possible.
The hierarchy established here is just absolute. The source text acknowledges that fixing hallucinations and expanding memory are important tasks,
Sure, they have their place.
but it definitively states that developing specialized ANSIs that excel at superintelligent logical and causal reasoning is the undisputed primary objective. If you solve reasoning, you solve everything else.
Logic is the master key.
Right. A perfect logic engine will deduce how to eliminate its own hallucinations, because a hallucination is simply a logical error. It will optimize its own memory storage.
And its framework requires a complete reallocation of our resources and our philosophy.
Otherwise, to change course.
We have to stop being enamored by parlor tricks. I mean, a machine that can generate a photorealistic video from a text prompt is mathematically impressive, sure.
But structurally hollow if it doesn't understand the physical laws governing the light, the gravity, and the objects in that video.
Precisely. We have to transition from building giant superficial pattern matchers to constructing cold, rigorous architectures of pure reason. We must build the AI equivalent of the scientist, not the encyclopedist.
Well, we've covered massive ground today, deconstructing the very nature of intelligence from the ground up. We started by dismantling the myth that memory and data processing are the hallmarks of genius, recognizing instead that true breakthroughs rely on the invisible structural threads of cause and effect.
Right.
We looked inward, stripping the magic away from human intuition, realizing that even our most profound eureka moments are simply the output of an unconscious logic engine tirelessly grinding through variables in the dark.
We then turned that lens outward to the machines we are building. We confronted the hard, physical reality of the brute force era, the data walls, and the collapsing energy grids.
And recognized that our current strategy of infinite scaling is a thermodynamic impossibility. The only escape hatch is a radical shift toward efficiency, which demands an architecture built entirely on fundamental axioms, laws, and strict causal reasoning.
We accepted the humbling reality that our biological hardware is no longer sufficient to solve the complexities of the modern world. We must build specialized, narrow super reasoners.
Systems like Sakana's AI scientist.
Exactly. Systems that abandon blind guessing for highly structured, logic-driven experimentation. Systems designed not to mimic human thought, but to vastly exceed it.
All of this pointing toward an endgame that is both awe-inspiring and deeply alien. An artificial superintelligence operating continuously above a 190 IQ, capable of rewriting the foundational laws of physics, inventing new mathematics, and seeing the causal architecture of the universe with a clarity that humanity could never achieve.
It's a staggering thought.
It really is. And for you listening, this fundamentally changes how you should view your own mind. The next time you are agonizing over a complex problem and the solution suddenly snaps into focus while you are washing the dishes, recognize what just happened.
It wasn't a muse.
No, wasn't random inspiration. It was your unconscious logical engine. That silent supercomputer in the basement of your brain, mapping the counterfactuals, isolating the variables, and executing a flawless chain of causal reasoning. That beautiful silent machinery is exactly what we must now desperately encode into silicon.
Truly.
But I want to leave you with a final, lingering thought to explore, extending directly from the prospect of an intelligence dwarfing Isaac Newton. If we actually pull this off, if we successfully architect a purely causal super reasoner and it does what it is designed to do, what happens when it discovers those new axioms?
That's the million-dollar question.
If an entity with an IQ of 300 invents a new branch of mathematics to explain a dimension of physics we cannot perceive, how does it communicate that discovery to us? We assume that a superintelligence will solve our problems and just hand us the answers.
He might not even be able to comprehend the answers.
Exactly. If its reasoning operates on a plane of reality fundamentally inaccessible to human biology, its pure, unadulterated logic might simply look like incomprehensible noise to us. We are rushing to build the ultimate translator of the universe without stopping to ask if we will even be able to read the language it writes in.